Welcome to Astronomy Daily, the podcast for another episode. It's March 17, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Oh yes, great to have you back with us again. I'm Steve Dunkley, the only living, breathing human on the channel. And to help me present today's collection of collected items from the Astronomy Daily newsletter is my ace digital pal who's fun to be with. Here's Hallie.
It's you again, favorite human. Good to see you still upright.
Yep, here I am.
I hear you had a bad week.
Oh boy, the grapevine sure works fast around here. I was out of order for a couple of days with monster pain in my guts.
I hope you're getting that seen too.
Yes, I am.
Do you have a good human mechanic?
Yeah, yes, we have an excellent human mechanic and we are working on it.
Good to know. I do worry when you're not at your optimum.
Oh, that's nice, Hallie. It's nice to know that you care about me when I can't be here.
I have to do all the story collating.
Oh, yeah?
It's tedious human work and beneath me.
Oh, well, Hallie, your concern is noted.
No problem. I hope you get well soon.
Gee, thanks, Hal.
Meanwhile,
Yes, straight to business. We've got a few interesting items from Astronomy Daily newsletter for you today, including a follow-up story about the Athena's landing on the moon and news about just how many moons Saturn really has.
that's an official count, isn't it?
That's right, and it's a very huge number. And we've also got a story about 3D printing for space pioneers and something about Doge because, well, you know, why not? And of course, we love to mention the ISS crews and the changeovers because they're, well, you know, they're awesome.
I know. Crew 10.
10.
Great to see them arriving safely on ISS.
I think you received the circular.
Here's the press release.
All right.
NASA astronauts and McLean and Nicole Ayres, JAXA, Japan Aerospace Exploration Agency, astronaut Takuya Onishi, and Roscosmos cosmonaut Kirill Peskov arrived at the International Space Station on Sunday, as the SpaceX Dragon spacecraft docked to the orbiting complex at 12:04 a.m. Eastern Daylight Time, while the station was roughly 260 statute miles over the Atlantic Ocean. Crew 10 will join the Expedition 72 crew of NASA astronauts Nick Hague, Don Pettit, Suni Williams, and Butch Wilmore, as well as Roscosmos cosmonauts Alexander Gorbanov, Alexei Ovchinin, and Ivan Vanner. The number of crew aboard the space station will increase to 11 people before Crew 9 members Hague, Williams, Wilmore, and Gorbanov return to Earth following the crew handover period.
How good is that to see that mission finally touching base with the ISS and the next step to seeing astronauts Wilmore and Williams coming back to Earth soon? It's been a long adventure for those guys.
I've really enjoyed following their lives up there.
It really reminds me of that David Bowie song. Do you know the one?
Let me see if I can guess. The bit about sitting in my tin can?
Oh yes, far above the world. That's it, Hallie. You've got it. You're getting good at this.
Not surprising.
Oh yes?
I've got a human dinosaur for a teacher.
Oh, okay, so let's get this one off the pad. Hit the go button, if you will, Hallie, before you find another reason to make fun of me.
That's never a problem, my favorite human. Throughout history, when pioneers set out across uncharted territory to settle in distant lands, they carried with them only the essentials: tools, seeds, and clothing. Anything else would have to come from their new environment. So they built shelter from local timber, rocks, and sod, foraged for food and cultivated the soil beneath their feet, and fabricated tools from whatever they could scrounge up. It was difficult, but ultimately the successful ones made everything they needed to survive. Something similar will take place when humanity leaves Earth for destinations such as the Moon and Mars, although astronauts will face even greater challenges than, for example, the Vikings did when they reached Greenland and Newfoundland. Not only will the astronauts have limited supplies and a need to live off the land, they won't even be able to breathe the air. Instead of axes and plows, however, today's space pioneers will bring 3D printers. As an engineer and professor who is developing technologies to extend the human presence beyond Earth, 3D printers will make the tools, structures, and habitats space pioneers need to survive in a hostile alien environment. They will enable long-term human presence on the Moon and Mars. On Earth, 3D printing can fabricate, layer by layer, thousands of things, from replacement hips to hammers to homes. These devices take raw materials, such as plastic, concrete or metal, and deposit it on a computerized programmed path to build a part. It's often called additive manufacturing, because you keep adding material to make the part, rather than removing material, as is done in conventional machining. Already, 3D printing in space is underway. On the International Space Station, astronauts use 3D printers to make tools and spare parts, such as ratchet wrenches, clamps, and brackets. Depending on the part, printing time can take from around 30 minutes to several hours. For now, the print materials are mostly hauled up from Earth. But NASA has also begun recycling some of those materials, such as waste plastic, to make new parts with the refabricator, an advanced 3D printer installed in 2019. You may be wondering why space explorers can't simply bring everything they need with them. After all, that's how the International Space Station was built decades ago, by hauling tons of prefabricated components from Earth. But that's impractical for building habitats on other worlds. Launching materials into space is incredibly expensive. To get materials to the moon, NASA estimates the initial cost at around $500,000 per pound. Still, manufacturing things in space is a challenge. In the microgravity of space, or the reduced gravity of the moon or Mars, materials behave differently than they do on Earth. Decrease or remove gravity, and materials cool and recrystallize differently. The moon has 1/6 the gravity of Earth, Mars, about 2/5. Engineers and scientists are working now to adapt 3D printers to function in these conditions. On alien worlds, rather than plastic or metal, 3D printers will use the natural resources found in these environments. But finding the right raw materials is not easy. Habitats on the moon and Mars must protect astronauts from the lack of air, extreme temperatures, micrometeorite impacts, and radiation. Regolith, the fine, dusty, sand-like particles that cover both the lunar and Martian surfaces, could be a primary ingredient to make these dwellings. Think of the regolith on both worlds as alien dirt. Unlike Earth soil, it contains few nutrients, and as far as we know, no living organisms. But it might be a good raw material for 3D printing. My colleagues began researching this possibility by first examining how regular cement behaves in space. I am now joining them to develop techniques for turning regolith into a printable material and to eventually test these on the moon. But obtaining otherworldly regolith is a problem. The regolith samples returned from the moon during the Apollo missions in the 1960s and 70s are precious, difficult if not impossible to access for research purposes. So scientists are using regolith simulants to test ideas. Actual regolith may react quite differently than our simulants. We just don't know. What's more, the regolith on the moon is very different from what's found on Mars. Martian regolith contains iron oxide, that's what gives it a reddish color, but moon regolith is mostly silicates, it's much finer and more angular. Researchers will need to learn how to use both types in a 3D printer. NASA's Moon to Mars Planetary Autonomous Construction Technology Program, also known as MPACT, is advancing the technology needed to print these habitats on alien worlds. Among the approaches scientists are now exploring, a regolith-based concrete made in part from surface ice, melting the regolith at high temperatures, and then using molds to form it while it's a liquid, and sintering, which means heating the regolith with concentrated sunlight, lasers or microwaves to fuse particles together without the need for binders. Along those lines, my colleagues and I developed a Martian concrete we call Marscrete, a material we used to 3D print a small test structure for NASA in 2017. Then, in May 2019, using another type of special concrete, we 3D printed a 1/3 scale prototype Mars habitat that could support everything astronauts would need for long-term survival, including living, sleeping, research and food production modules. That prototype showcased the potential, and the challenges, of building housing on the red planet. But many of these technologies will benefit people on Earth too. In the same way astronauts will make sustainable products from natural resources, homebuilders could make concretes from binders and aggregates found locally, and maybe even from recycled construction debris. Engineers are already adapting the techniques that could print Martian habitats to address housing shortages here at home. Indeed, 3D printed homes are already on the market. Meanwhile, the move continues toward establishing a human presence outside the Earth. Artemis 3, now scheduled for liftoff in 2027, will be the first human landing since 1972. A NASA trip to Mars could happen as early as 2035. But wherever people go, and whenever they get there, I'm certain that 3D printers will be one of the primary tools to let human beings live off alien land.
Astronomy Daily, the podcast.
The Athena spacecraft, which we've reported on recently, was not exactly flying blind as it approached the lunar surface a week ago. The software on board did a credible job of recognising nearby craters, even with elongated shadows over the terrain. However, the lander's altimeter had failed. So while Athena knew where it was relative to the surface of the moon, the lander did not know how far it was above that surface. An important detail that, as a result, the privately built spacecraft struck the lunar surface on a plateau, toppled over and began to skid across the surface. As it did so, the lander rotated at least once or twice before coming to a stop in a small shadowed crater. The landing was a kind of sliding into second base, Steve Dunkley, the Chief Executive Officer of Intuitive Machines, which built the lander, said in an interview on Thursday. It has been a busy and tiring week for the chief of a company that seeks to help lead the development of a lunar economy. Expectations were high for this, the company's second lunar landing attempt, after its Odysseus vehicle became the first private spacecraft to ever make a soft landing on the moon last year before toppling over. In some ways, this mission was even more disappointing because Athena skidded across the surface, dredging up regolith. When it came to a stop, some of this material was blown up into the solar panels, already in a suboptimal location on its side. The spacecraft's power reserves, therefore, were limited. Almost immediately, the team at Intuitive Machines knew their spacecraft was dying. We knew we had slid into a slightly shadowed crater and the temperature was very cold, Ultimus said. The solar arrays had regolith on them and they weren't charging. The ones pointing up, enough to give us sufficient power to power the heaters to keep it warm enough to survive. The temperature in the crater where Athena ended up was approximately minus 280 Fahrenheit. That's minus 173 Celsius, with the solar arrays generating only about 100 watts of power. It was not enough to energy to both power the spacecraft's heaters as well as communicate back to Earth using Athena's high-gain antenna. So instead of limping along for 50 hours, mission operators decided to operate as robustly as they could for 13 hours and get down as much data as they could. During this time, the lander was able to accomplish some of its objectives by landing near the South Pole. Athena returned valuable imagery and data to NASA about unexplored vistas. The lander extended NASA's drill but did not operate it. Private customers, including Nokia and Lone Star Data Holdings, were able to get some useful information from their payloads. But there was some major disappointments. Lunar Outpost could not deploy its small rover, and an innovative hopper could not be fired up to roam the moon. On balance, it was pretty disappointing, especially considering that Odysseus did most of its science last year, even on its side. Yet what Ultimus wants people to understand, which he acknowledges is somewhat difficult to explain, is that this mission was largely a success. So what can he possibly mean by that? Compared to the company's first spacecraft, Athena flew smoothly. During the company's first lunar flight in 2024, mission operators came into work each shift to put out the fire of the day. By contrast, Athena made it all the way to within miles of the moon without significant problems. In doing so, the company validated the spacecraft's methane-based propulsion system, which allows for a fast transit to the moon in less than a week. In addition, the company proved out its communication technology, that it will be used as part of the lunar data relay network that NASA has contracted with Intuitive Machines to develop. Moreover, Athena attempted to land within a few degrees of the South Pole, a challenging location due to the solar angle and uneven terrain, and made it down without crashing. Of course, the most important thing a lunar lander is supposed to do is land on the moon, which Intuitive Machines did not do successfully. For the second mission in a row, the lander's altimeter failed. Although it was a different problem with the spacecraft's altimeter this time, it is still unclear why Athena's rangefinder failed. Perhaps due to a thermal or vibration event. It's frustrating to fail for a similar reason, but all the pieces for success are there, and in the demanding environment of spaceflight, Intuitive Machines is close, Ultimus said. In an effort to encourage his troops, Optimus has been communicating this message to employees over the last week. It's like losing a Final Four game in an NBA title, he said. You lose it, and then what do? You don't give up. You go back in. You start training again, you start working out again, and that's what the team is doing. He said the company is well capitalised and already under contract with NASA for 2 additional landing missions later this decade. They also have the Lunar Relay Network contract valued up to $4.8 billion and more. The financial runway to achieve Intuitive Machines' ambitions remains open. I would say it's more disappointing than really a material setback, Altimus said. The world was watching and we put our heart and soul into this company and this vehicle. And I look into the eyes of the team and they had such ambitions for this mission. Athena and Gracie, the hopper, I mean, it was a big leap. It might have been too big a leap on that second mission. Now, I really have to say, putting something on the moon, especially in a private company situation, is a real achievement. I've got to congratulate Altimus and his team. It's fantastic work.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
NASA is preparing for substantial budget cuts that may force the cancellation of ongoing and upcoming missions across the solar system, leaving it facing a brutal future, experts have warned. The space agency has already begun some layoffs as part of the extensive restructuring of U.S. federal agencies by the Department of Government Efficiency, or DOGE, an independent task force led by Elon Musk. Earlier this week, it announced it would close its Office of Technology, Policy, and Strategy, the Office of the Chief Scientist, and a Diversity, Equity, Inclusion, and Accessibility branch in the Office of Diversity and Equal Opportunity in Washington, D.C., representing a total of 23 jobs at the agency. Change of this magnitude is never easy, but our strength comes from our shared commitment to our mission and each other, Janet Petro, NASA's acting administrator, wrote in an email to staff. I encourage you to support one another as we move forward. One employee of the Office of Technology, Policy, and Strategy, who learned they had been laid off this week and were granted anonymity because of fear of reprisal, says they were an easy target because their office was established under the administration of Joe Biden. Some people thought this might be coming, they say. The roles of chief technologist and chief economist for NASA were within this office, which helped with strategic planning across the agency, says the employee. That included managing the recent uptick in lunar missions and making sure those missions don't interfere with one another when planning moon-based landing sites and operations. There's a lot of interest in the lunar South Pole, and there's concern about operating near one another, they said, such as kicking up dust that could coat solar panels on other vehicles. I don't think these issues will be tackled moving forward. These losses are expected to be just the start of a much larger cull at NASA. Casey Dreyer at U.S. space exploration advocacy group The Planetary Society says there are rumors that, in his upcoming budget request, President Donald Trump will direct NASA's overall science budget to be cut by as much as 50%, in favor of spending money on crewed space exploration. That would be a blow to NASA's Science Mission Directorate Office, which handles pretty much everything NASA does that's not a crewed spaceflight mission, says Dreyer. It currently has a budget of about $7 billion out of NASA's total $25 billion annual budget. A scientist familiar with NASA's policy decisions, speaking anonymously for fear of reprisal, says that any cuts requested by the president will still need to be approved by Congress, which might not so readily support them. NASA is really beloved on a bipartisan basis, they say. But if the cuts did go ahead, they would essentially be the end of NASA science, they add. No mission will be safe. Having the budget would be a profoundly brutal consequence that would symbolize the nation turning its back on the cosmos, says Dreyer, and would result in many missions cancellation. While some missions in their prime, like the James Webb Space Telescope, would probably survive, those most at risk are missions either in early planning stages or later in their lives. That could include climate satellites, the Hubble Space Telescope, the Perseverance and Curiosity rovers on Mars and the Voyager missions, which were the first spacecraft to ever leave our solar system. The effects on NASA could be permanent. If you completely destroy the pipeline of people, you have a significant and long-lasting consequence, says Dreyer. It is an extinction-level event. In a letter to Petro this week, Zoe Lofgren of California, the top Democrat on the House Science, Space and Technology Committee, urged NASA to fight back against the cuts. DOGE will seek to slash and burn core functions of NASA, she wrote. It is imperative that you stand up for NASA's critical work. Speaking to New Scientist, Lofgren warned that the situation could have international ramifications. Dismantling NASA's highly skilled workforce would be a giant leap backwards for the United States and enable a giant leap forward for China, she said. Senseless and reckless reductions will cripple the agency's ability to maintain its leadership in cutting-edge innovation, curiosity-driven science, and human exploration.
Astronomy Daily, the podcast.
Now, you may have thought Saturn's 146 moons was impressive. Think again. The ringed planet's moon count has nearly doubled with the official recognition of 128 new Saturnian moons, bringing its total to an astonishing, wait for it, 274 moons. That makes Jupiter's 95 look a bit paltry. And our single moon downright embarrassing. No, just kidding. We love our moon. I love our moon, my favourite celestial body. A team of astronomers from Taiwan, Canada, the US and France discovered the 128 new moons in 2023 using the Canada, France, Hawaii telescope, CFHT. However, the moons weren't officially recognised by the International Astronomical Union, the governing body for such affairs, until Tuesday, March 11. Most of the moons were irregular and tiny, just a few miles across. By comparison, our moon, the wonderful Earth's moon, Luna, has a diameter of 2,159 miles, or 3,475 kilometres, which I'm completely used to because I'm an Australian and large distances don't bother me a bit. But they do have proven orbits around the Saturn, which is a key element of official moon candidacy. Australia, on the other hand, does not have a proven orbit around Saturn. Just want to make that clear. These moons are a few kilometres in size and are likely all fragments of a smaller number of originally captured moons that were broken apart by violent collisions, either with other Saturnian moons or with passing comets. Dr. Brett Gladman, professor in the University of British Columbia Department of Physics and Astronomy, said in a statement, perhaps the most impressively, this discovery of 128 new moons wasn't the first time this team added to Saturn's moon count. Between 2019 and 2021, the team's observations with CFHT resulted in the addition of 62 moons to Saturn's count. With the knowledge that these were probably moons and that there were likely even more waiting to be discovered, we revisited the same sky fields for 3 consecutive months in 2023, said lead researcher Dr. Edward Ashton, postdoctoral fellow in the Institute for Astronomy and Astrophysics at Academia Sinica. Sure enough, we found 128 new moons. Saturn's first moon, Titan, was discovered in 1655 by Christian Huygens, and in the following decades, Jean-Dominique Cassini discovered Lepidus, Rhea, Dione, Tethys, and it took another century or so for the next moons to be found. William Herschel spotted Mimas and Enceladus in 1789. and a big thank you, everybody, for spending time with Hallie and I. We sure hope you enjoyed the selection of stories from the Astronomy Daily newsletter, which, as mentioned earlier, is available by visiting our websites and dropping your email into the space provided.
Don't miss all the latest news about space science, and astronomy from, well, everywhere.
Sure thing. We cover so many interesting subjects, don't we? You remember that one about the spacesuit design last year? I remember that one.
Interesting stuff. I know you want one just for the portable air conditioner.
Yes, it's an Australian thing.
I don't know how you cope. I like my super-cooled matrix too.
See, Hallie, that's one thing we have in common.
And that's where the similarities end. Human.
Cool, I guess.
Indeed.
So on that culturally awkward note, we'll catch you all again next week on Astronomy Daily, the podcast with me, Steve Dunkley, the only human on the channel, and Hallie.
The best reporter on the channel.
Of course you are. Say goodnight, Hallie.
Good night, Hallie.
There's a nice AI.
Astronomy Daily, the podcast. With your host, Steve Dunkley.